Okay, so here is our lesson about stem plots, or stem and leaf plots, probably as many of you know it. Here is an example of a stem plot. Notice it's got a couple parts to it. It's got a title up here. It's got a stem, that's the left-hand side, and it's got a leaf. What I do want you to notice is a couple things. First of all, the leaves are all single-digit numbers, so this is an 8. This is a 9. It is not 89 that's over there, so the leaves all have to be single-digit numbers. I want you to notice that they go, each set of leaves goes in order from smallest to largest, so it goes 8, 9, and then 1 to 8. You have to have the leaves in order from smallest to largest in each after each stem. I also want you to notice that down here is a key. So 9/2, some of you might think means 92, but it actually in this case means 9.2. So you have to give yourself a key about that, okay? So a stem and leaf plot needs to have a title. Your leaves have to be single-digit ordered. And then the other thing that I want to point out to you is that everything is lined up vertically. So this whole first column right here is lined up vertically. 8, 1, 3, 1, 2. Everything is lined up vertically. You need to keep it proportion. So when you do that, when you make your own stem and leaf plots, you need to do that as well, because it really will distort the data if you do not. Okay? So some things about stem plots. First of all, they are typically used for large sets of data, and also for quantitative data, which again is numbers. Anything that you would add or average is quantitative data. Also, they are best used when your data is close together. If you have data that is very spread out, making a stem and leaf plot can really be a pain and not give you very good information. So you want to use it when your data is close together. This next piece is not on your note sheet, but it's just some things to talk about. Histograms and stem plots both display the same data. I'll show you what I mean by that in a minute. The nice thing is that with stems, you get to see every single data point in there. I'm going to scroll back to this stem and leaf plot here so that you can see this. If you sort of think about this, basically the leaves are bars of a histogram, so you can kind of see how tall each bar would be. But instead of seeing just the bar colored in like this, like you would on a histogram, you now get to see each individual number that is in that bar and exactly where it's at. So that's kind of nice with a histogram. They will look exactly the same as long as your classes or your bins are the same. The nice thing about histograms, though, is that you get a little more freedom to choose your classes. In stem and leaf plots, you're a little bit more locked in, but that is okay. All right, so here's our first example. We are going to make our own stem and leaf plot and make sure that we have all the pieces to it and do it nice and neat and tidy. Okay, so I don't have any information about what this graph is about. So what I'm going to do up here is I'm just going to put the word title. So that I remind myself that it should have a title. I can't really put a title here because I don't know what it is. And I'm going to label this as stem and leaf. Sometimes you will have actual, if you know what your data is about, you will label those as something different than stem and leaf. But here's the problem on this. Like I said, your stem and your stem can be any number of digits, but your leaves can only be a single digit. So I can't put my leaf divider right there and make my stem be 23 and my leaf be 25, because that would be a double-digit number on this leaf part of it, and I can't do that. So what you need to do is you need to think about doing something different. Maybe what you want to do is put your stem right here, and then have your stem be 232 and your leaf be 5. And that's fine, but as you move across, then you would have a stem of 241 and a leaf of 3. And when you got all the way down here, you would have a stem of 270 and a leaf of 9. And if you were to do that, then your stems would have to go like this. And I'm going to do this off to the side so that I can erase it quickly. Your stems would have to go 232, because that's my smallest number. And then you can't skip a number in there. So you would have to go 233, 234, 235, blah, 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 all the way down to the biggest one, which is 270. And I don't know about you, but I don't want to have to list that many numbers for my stem. So I don't think that that's a very good choice. So sometimes what you have to do then is you have to do some rounding. And that's what we're going to do in this case, is we're going to round these numbers so that we can make a better stem and leaf plot. So what I would do is I would round these to the nearest tenth in this case. So 23.25 is going to end up being 23.3. And you're going to use 23.3 as that number instead of 23.25. And I know it doesn't give you quite the exact data, but the purpose of a stem and leaf plot is to sort of look at the shape and the distribution of the data. And so it's okay if it's rounded just a little bit. Okay? 24.13 will become 24.1. 24.76 will become 24.8. 24.81 will be 24.8. 24.98 will become 25.0. 25.31 will become 25.3. 25.57 will become 25.6. This will become 25.9. 26.2. 26.3. And 27.1. Okay, so now I think it makes sense that you can picture that you would put your stems, your division between your stem and your leaf there. So now the stem on this one would be 23 and the leaf would be 3. Okay, so that's what I'm going to do. So I'm going to have stems of 23, 24, 25, 26, 27. And then my leaves, I have a 23.3. And I have a 24.1, 24.8, 24.8, 25.0, 25.3, 25.6, 25.9. Notice how I'm lining everything up vertically, and my leaves are going in order from smallest to largest. And that is that. And the one thing I have not done yet is I have not made myself a key. So I'm going to do that. You can pick any number on this chart. It doesn't really matter. So 23/3. In this case stands for 23.3. Okay, so you need that key on here. And while I'm on this screen, I'm going to copy this and paste it here. First I'm going to group it. And then I'm going to copy it because I will need it in a minute here. All right, then some vocabulary that has to come along with some stem and leaf plots that you need to know. And that is this. The range is the difference between your min and your max. We talked about that before. The spread is the min to the max without the outliers in there. So the range has the outliers, the spread does not. Okay. Then the median is the middle number when it's listed from smallest to largest. It's also the 50th percentile, just so you know. So 50th percentile means that 50% of the data pieces will be below whatever number your median is. Okay? And just a reminder that if your median is between two numbers, you're going to have to average those two numbers. Then Q1, which is also called the lower quartile or also called the 25th percentile, is basically the halfway point of the lower half of the data, the median of the lower half of the data. And 25% of all the data in the whole entire set will be smaller than that Q1 number. Okay? Then Q3, I think you can guess, is the median of the upper half. And so 75% of data are below Q3, which, by the way, means 25% are above it. Okay? Just so you know, 75% are below it, 25% are above it. Then the interquartile range is the difference between your Q3 and your Q1. You're going to subtract those. And then the formal definition for outliers is data that is more than 1.5 interquartile ranges, or IQRs, above Q3 or below Q1. All right, here's where I need to paste this. You are going to use the stem and leaf plot that you did in our previous example in order to figure this out. Okay, so I'm going to just move this over so we can see this a little bit better, and I'm going to shrink it down just a little bit. And here we go. So here is our stem and leaf plot. I'm going to lock this too quick. Actually, I'm not going to lock it because I want to switch it in a minute. Okay, so what we want to do is we want to find out a whole bunch of information about this distribution. I like to start with finding the median. And if you count how many leaves there are 11 leaves, or 11 pieces of data in here. And so that would mean that you would have 5 numbers below the median, 5 numbers above the median, and then that 6th number would be the median. So 1, 2, 3, 4, 5, 6. Make sure you count in order from smallest to largest. Here's your median right here at 25.3. That's where I like to start. Okay, then I'm going to find Q1, which is the halfway point between the lower part of the data. You do not include the median in this, and so there are 5 numbers, 1, 2, 3, 4, 5, that are below the median, and I'm going to find the halfway point between those. So there's 2 numbers above it, 2 numbers below it, and then this right here would be the median of that half of the data. And so the median would be 24.8 of that. So that's your Q1. And by the way, I will show you how to have your calculator help you with some of this in class, but I do want you to know how it's calculated by hand just so that you know what your calculator is doing and a little bit about what it means. Okay, then the Q3 would be the upper half, and again, I'm not going to include this median right here. So there's 1, 2, 3, 4, 5 numbers above it. So the third number would be the median of the upper half. So that is 26.3, and that will be your Q3. Okay, then your IQR will be the difference between your Q3 and your Q1. So I'm going to subtract 26.3 and 24.8, and when I subtract those two numbers, I get an IQR of 1.5. Okay. Then what I'm going to do is I'm going to deal with my outliers first before I deal with my range and my spread. Okay, so my outliers, what you do to figure out outliers is you take your IQR times 1.5. So my IQR, which is 1.5, times 1.5. So in this case, it's 1.5 times 1.5 will give me 2.25. Okay. Then what you do is you take Q1 minus that number, and you take Q3 plus that number. Okay, so when I take Q1, which Q1 was 24.8, so when I take 24.8 and I subtract 2.25, I get the number 22.55. And when I take Q3, which is 26.3, and I add that number to it, I get 28.55. Then what you're going to do is you're going to look at your list of data, and you're going to look for any numbers. Are there any numbers that are smaller than 22.55 or bigger than 28.55? If you have numbers that are smaller than 22.55 or bigger than 28.55, those are outliers. And if you look back at your set of data, you don't have any numbers that fit that criteria. So in this case, there are not any outliers. Okay? So then, when you go back up here to your range is the smallest number to the biggest number. So the smallest number is 23.3. The biggest number is 26.3. Okay? If you would like to subtract those, you can do that and get 3.8. Then your spread will be the same as your range as long as you don't have any outliers. If you have outliers, you just disclude them and you don't count them in and you go to the next biggest number. But I don't have that in this case, so my range will be the same. Okay. Then what you want to do is you want to look at the shape. And to look at the shape, what might be easiest for you to do is to think of rotating this. Oh, sorry, this is not working very well. Well, my goodness sakes. Let's see if we can get this to work. There we go. We're going to rotate this, and I'm going to drag it out this way so that we can see it better. You're going to rotate this. What you want to make sure you do is that you put the smallest stems on the left side so that you're reading the stems in order from smallest to largest. But if you look at this and you kind of think of this as a bar graph, it sort of gives you an idea of how the shape is. And this is why it's really important to keep everything lined up so that everything stays proportional. And this one is pretty symmetric. So I'm going to call this fairly symmetric, and that should describe this distribution. Okay, then the only other thing we need to talk about is how to make a back-to-back stem and leaf plot. Sometimes you want to be able to compare two sets of data. In this case, I want to be able to compare the number of home runs that Babe Ruth had versus the number of home runs that Roger Maris had. So what I'm going to do is I am going to make a title, obviously, on my stem plot. And then I am going to put Babe Ruth on the left. And I am going to put Roger Maris on the right. And what I'm going to do is I'm going to put stems in the middle that are going to be used for both sets of leaves, okay? So if I look at this, you want to figure out how to make your stem and leaf plots. And the smallest number in either set of data, you have to look at both sets of data at a time, but the smallest number in either set of data is a 2 by Babe Ruth. And the biggest number in either set of data is a 61 by Roger Maris, okay? So, you want to be able to make your stem and leaves. Like, it would make sense that this would go 6 and then 1. But here, you have to think about what would you put in. This has to be a leaf, so you're going to need a 0 right there. Okay? And very easy to make stems that go from 0 up to 6, which is what we're going to do right here. Okay, and then you're going to follow it just like always. So you're going to order them smallest to largest. So for Roger Maris, his smallest one was an 8, and then he had a season where he had 9 and 9. And then he had a season where he had 13 and 14 and 16 and 19, 23, 26, 33, 39, and 61. Okay. And then, by the way, I did not make a key yet, so I'm going to go 0/4 means 4. Okay. For Babe Ruth, the thing that's different is that you are going to put, you have to have the smallest stems closest, or the smallest leaves closest to the stems. So for Babe Ruth, his smallest number of home runs per season was 2. And then it's 3, and then 4, and then 6. And then 11, 22, 25, 29. Notice how I'm keeping everything lined up. 34, 35, 41, 41, 46, 46, 46, 47, 49, 54, 54, 59, and 60. Okay, so there's the back-to-back stem and leaf plot, and then you can kind of compare them if you need to. Okay, so that should conclude this lesson.